All right, talking about graphing logarithmic functions. F of x equals log base b of x. G of x equals a times log base b, x minus h plus k. Ladies and gentlemen, that a and that h and that k, they're all doing the same thing. A stretches the graph vertically, h translates it horizontally, the opposite direction of what it's showing, and k translates vertically. So here in pink we have f of x equals a log of x. Whenever the b is not actually written as a number, that does mean it's a base 10. So that would be a 10 in there. So what we are graphing here is log of base 10 of x. So we do a little table of values. The easiest way to do these table of values is to say that 10 to the y equals x. Excuse me, let's call this, hate it when they do x's and y's. X equals y. So we plug these values in and we get our y values. So if we plugged in 0.1, we'd get -1 and so forth and so on. Now, this is what the graph looks like. Asymptote, x equals 0, x equals h. Reference points are 1, 0, and b, 1. So whatever our base value is, that's going to be here for b. To make the translations, this is a little bit different. We add the h value here, so if h is positive, we add. If it's negative, we subtract. And the k value, because if I add 0 to anything, it's just going to be k, even if I have to multiply by something. Here, we get the b value is b plus h, a times 1 plus the k. So here, yes, we're multiplying by a, but a times 0 is just 0, so we don't really consider it in. So this is what our parent function looks like. We're going to be comparing translations to the parent function, and we're going to be talking about what those translations look like in words and on the graph. So we're going to slide our little board down. All right. This says to identify the transformations of the graph f of x, log base b of x, that produce the graph of the given function g of x. So here's our g of x. Then graph g of x in the same coordinate plane as the graph f of x by applying the transformations to the asymptote x equals 0 to the reference points. Also state the domain and the range. All right, so these are our reference points. This is our asymptote is at x equals 0. Here's first reference point, 1, 0. And then remember, it's b comma 1. In this case, b is 2. So that's our parent function for this. I've already graphed in the parent function. The green dotted line is the asymptote. The blue line is the f of x function. Now, what I'm going to take you through is the changes, what happens here, and then we'll write it out in words. It doesn't matter the order in which you do the wording, but we're going to look at the transformations. So this says our asymptote is going to be x equals h. Our h value is 1, so our asymptote for our g of x is right here, x equals 1. These are vertical asymptotes. Not sure you guys, you can see that a little bit. Then the new function, it's 1 plus h. So in this case, h equals 1. Our a value is -2, and our k value is -2. So we're going to use those values when we plug them in here. So this says I take my 1 and I'm going to add the h. This is the same thing we've been doing. So we add the h value to here. So 1 plus 1 would give me 2. And then it's 0 times a, which is 0, plus the k value of -2. Here, b value plus h. Well, my b value is 2. I'm going to add the h value, 2 plus the 1. This is just like taking your reference points here and saying plus 1. This is times -2, and then not plus 2, but -2 to each one. So that would give us 2, -2, and the same thing here. This would be 3, and then multiply that by -2 minus 2 would give you -4. Same idea, it's just a different way of writing it in this table. Something it's helpful. Maybe you want to just go back to your reference points and do what we've been doing this whole time. So at positive 2 and negative 2 is our first point. And then at positive 3, negative 4 is our second point. Now, this one looks a little different than the other one. Because it's a negative, remember, when it's a negative, it's being flipped. It's having that reflection. So this one is going to go downward and come over. This is our g of x. G of x, if you go across that dotted diagonal line, then we would have those mirror images of each other. So let's talk and write in words. So since it's a negative and it's a, it's being reflected over the x-axis. The other change is it's stretched by a factor, stretched vertically by a factor of 2. We are translating our graph horizontally 1 unit right. And then this says we're translating our graph vertically down 2 units. And there we have our graph. Now, we are going to look at one more. Oh, wait, stop, go back. We forgot to do the domain and range. So before we get there, look at your domain of your pink. The domain is stopped. It's to the right of 1. So your domain, x such that x is an element of the reals, x is greater than, because it's to the right, of 1. That means in interval notation it goes from 1 to positive infinity. Our range is y such that y is an element of the reals, negative infinity to positive infinity, and interval notation, there we go. Our asymptote here, x equals h, since h is 1, that would be x equals 1 for that asymptote. All right, so we're going to move on down. We've got this equation over here. Move the little swivel so you guys can see this a little better. So our equation is g of x equals 2 times the log x plus 2 plus 4. I'm going to slide this over so maybe it gets a little bit clearer. Now, my asymptote, f of x equals x log base 10, because remember, when it's not written, it's there. So the asymptote is at 0. We get 1, 0. B is 10, so it's 10, 1. Again, asymptote's here, parent function's here. If I look at this, my a value is 2, my h value is negative 2, and my k value is 4. So if I look at my asymptote, that means my asymptote here is x equals negative 2. You can either use these formulas or go back to what we know. The a value gets multiplied to the y's and add 4. And then for the h value, we are going to subtract 2 or add negative 2. That would give me here 1 minus 2 is negative 1. 2 times 0 is 0 plus 4. For this one, it would become 10 minus 2 is 8. 1 times 2 is 2 plus 4 is 6. So if we look at this and just start getting in our information, we have an asymptote at negative 2. Remember, it's always vertical with the logs. We have a point at negative 1, positive 4, and at 8, positive 6. About right there. So our graph is kind of doing this. And I missed that point just a little bit. So there we go. There's our graph. Let's write in words our translations, what's happening. So it's not negative for A, so it's not being reflected. So it's being stretched by a factor of 2. We are translated and this is stretched vertically. Translated horizontally, let's see, it went actually left 2 units. And translated vertically up 4 units. Domain. X is greater than -2 because we have nothing to the left of it. So for interval notation, it'd be -2 to positive infinity. The range. The range is going all the way down, and it's going to keep going up, so it's going -infinity to positive infinity. And so for interval, that's -infinity, positive infinity. Same idea, same thing we've been doing every unit, domain and range, talking about the shifts in the translations.